At this point, you should have already seen properties of powers, and we're just going to extend that into rational exponents as well. Make sure you understand the power properties the right way. For example, the first one that I'm underlining here, don't just think of it as, oh, you just add the exponents. No, understand what the entire thing means. If you're multiplying powers with the same base, in this case a, you can simplify that by keeping the base and adding the exponents, and that becomes the new exponent. So here's an example with where the base is 5 and the exponent is a fraction. The rules are still exactly the same, and you can verify all this with a calculator. The second one is a power raised to a power. The third one, what's very important here is that you have a multiplication symbol in between the a and the b. If that was addition, you can't use the property. 4 is the reciprocal. The negative exponent acts like a reciprocal, and so forth and so forth. Let's do a few examples. So for the first one, so I'm just going to carve a line here to separate all this, and we're going to simplify. All right, for the first one, let's do 7 to the 1/4 power times 7 to the 1/2 power. All right, well, this is similar to the first rule, and all I have to do is keep the base, which in this case is 7, and I'm going to add the exponents, and we know that 1/4 plus 1/2 equals 7 3/4. So that's a correct answer, 7 to the 3/4 power. And we could also write it, we can write it in radical notation. However, the better way and simpler way is this. Okay, next example. 5 divided by 5 to the 1/3 power. Well, this looks like the quotient rule. I have the same base of 5, and the 5 in the numerator, its exponent is 1. So we keep the base, and we subtract the exponents. So this becomes 1 minus 1/3. And our final answer is 5 to the 2/3 power. Last example for this section, we have in parentheses 4 to the 5th power times 3 to the 5th power, close parenthesis, raised to the negative 1/5 power. If you look inside the parentheses, it's the opposite of this rule. So we could take that 4 to the 5th power times 3 to the 5th power, and because they have the same exponent, we could write it as 4 times 3, both raised to the 5th power, and all of that, I'll use a brace here, is raised to the negative 1/5 power. Four times 3, you can do this in whatever order you prefer. I'm going to do 4 times 3 first. That gives me 12 to the 5th power, all raised to the negative 1/5 power. And next, because I have power raised to a power, I can multiply the exponents. 5 times negative 1/5 gives me 12. Now I'll write the 5 times the negative 1/5. I get 12 to the negative 1 power, and then you just have to write it as 1/12. there's the final answer.